All right, question number 11. We have 5 parts. Looks like we're going to walk through the first derivative test. We're going to locate the critical points. Use the first derivative test to locate maximum and minimum values. And then we're going to identify the absolute maximum and absolute minimum values of the function in the interval when they exist. All right, so I'm going to try to work this whole thing out, and then we'll input the parts one at a time. So we got negative x squared minus x plus 3, and we are on the interval, closed interval, negative 5 to 5. First, we're going to find the derivative. Negative 2 subtract 1, so negative 2x. Give me a negative 1. Derivative of a constant is 0. We're going to set this equal to 0. So I'm going to say 2x, negative 2x, that is, minus 1 equals 0. Add 1, so we'll get a negative 2x equals 1. Divide by negative 2, so x equals negative 1/2. This is my critical point on the number line. Negative 5, negative 1/2, and then positive 5. So we get one critical point. We are going to test some values using this function. Easy number on the left side here is negative 1, so I'm going to use that as a test point. Over here, I'm going to use 0, so on the other side of the negatives. So if I plug in negative 1, I'm going to go ahead and write it all out. Negative 2 times negative 1 minus 1. Negative times a negative is a positive. Positive 2 minus 1 is a positive 1, so this is positive. And then plugging in a 0, we get a negative 2 times 0 minus 1, so we get a 0 minus 1, negative 1. So this is negative. So my function is going from increasing to decreasing. So that tells us we have like a max. This critical value is a maximum. And then once we identify that maximum value, we're going to plug in endpoints and critical value to find the absolute maximum and minimum. So I'm going to do f of negative 5, f of positive 5, and then f of negative 1/2. And we can plug them all in. Don't take that long. Positive 25 goes back to negative. So we got negative 25 plus 5. So we got negative 20. Negative 20 plus 3, negative 17. Do the same thing with 5. You get a 25 that's negative. Negative 25, and there'll be a minus 5, which will give you negative 30. Negative 30 plus 3 will give us a negative 27. And then if we plug in 1/2, that'll give us 1/4. So we'll get a negative 1/4. Negative will be plus 1/2. And then plus 3. Common denominator would be 4. So times 2 and 2. This will be times 4. And so we'll have a negative 1 plus 2 plus 12 all over 4. And that gives us 13 over 4. That's our maximum. And then this would be our minimum, negative 27. Alright, so we got everything done. Critical points. X equals negative 1/2. Well, I gotta check it. Alright, second part, locate the maximum value. There's a maximum at x equals 1/2, negative 1/2. When x equals negative 1/2, that was a maximum. Okay, locate the minimum value. So there was no local minimum in the interior. So there is no local minimum. I only had a maximum. All right, identify the absolute maximum value. So the absolute maximum value was 13 divided by 4. 13/4. All right, and then identify the absolute minimum value. So the smallest value we got was negative 27, because we're on the closed interval. So you evaluate the endpoints.